Hey guys, welcome back to your YouTube homework review. Your secret word is Hajale. Singing it a little bit. Alright, so time for something a little bit different. Last week during a number talk, we started exploring division problems that were equivalent to one another. So, for example, 18 divided by 6, we realized that this is equivalent to 36 divided by 12. And there were lots of reasons why we figured out this was true. One reason was it's sort of like these are ratios and they have the same constant of proportionality of times 3. We also see that they're halves of each other. Half of 36 is 18, half of 12 is 6. So all of these things seem to matter, but the easiest and strongest way I think to think about it is as ratios. 18 to 6 is equivalent to 36 to 12. And all division problems are ratios, and that's a cool realization that we can use to change weird problems into easier ones. So if we didn't like 18 to 6, we could have just divided both of those by 2 to get 9 to 3, and then just solve the division problem, 9 divided by 3. And since it's equivalent to the other two, it would give us the answer to all of them. So this really helps when we're dealing with decimals. So question A says 54 divided by 5/10. That is a strange problem because dividing by 5/10 is kind of challenging. So one option we have is if we think of that as a ratio, we can just make an equivalent ratio first. So what I'm going to do is I'm just going to multiply 54 and 5/10 by 2. 54 times 2 would give you 108. And then 5/10 times 2, well, that's just like 5/10 plus 5/10, which would be the same as 1, or 1 whole. So basically it gives us this unit rate of 108 to 1. So I know that this division problem must be the same as 108 divided by 1. And then this problem is really simple now because anything divided by 1 is itself, so the answer would be 108. Now, when you go back to the original problem, you might have a realization that Sabrina from 701 had, which is when you divide by something less than 1, it actually gives you a bigger answer, which can be a little strange, but it helps to reverse it and think of it as multiplication. Basically, we just figured out that 108 groups of 5/10 is equal to 54, and you also probably could have figured that out just by thinking about multiplication. And just so you can see it if you wanted to do it, we know that one group of 5/10 is just 5/10. We figured out earlier that if we multiplied it by 2, that's the same as 1 whole. And if we're trying to get to 54, it's almost like we took this and we multiplied it by 54, and we got this new problem. 108 times 5/10 equals 54. So that would have been another way to get this answer, but that also might be a little complicated for you, in which case having and having could also be used. Alright, so let's take a look at B. B says 16 divided by 25 hundredths. And again, we're dividing by something small and it's a little weird. So we could think of this as a ratio of 16 to 25 hundredths. And then we can say, let's solve a simple division problem, or a simpler division problem. So I see that if I think of it as a quarter, 4 of them would make a whole. So I'm just going to use 4 to make an equivalent ratio. 25 cents times 4 gives us $1, or just 1 whole. And then 16 times 4 gives us 64. So that means we can rewrite this problem as 64 divided by 1. Those are going to be equivalent. And 64 divided by 1 is super easy. The answer is just 64. And again, if you try and reverse it and try and make sense of the problem, we basically just figured out that 64 groups of 25/100ths is equal to 16. And it's kind of cool, you actually can think of this as money. If you have 64 quarters, that's going to be the same as $16. And you can even prove it like this, just to show you. 4 groups of a quarter is $1. That would mean that 8 groups of a quarter would be $2. And you can kind of keep on going until you realize that 64 quarters is going to be the same as $16. Let's continue with this strategy of thinking of division as a ratio to help rewrite the problem. So C is the same as this ratio, negative 20 to 2/10. Something you could do here, other than going to a whole, is you could do just multiplying this ratio by 10. And what's cool is we spent a lot of time in the percent unit realizing that if something like 2 was 10%, then dividing it by 10 would give you 0.2. Right? You guys did that so much. So now, if we do it the other way around, 2/10 times 10 is just going to go up to 2 wholes. And you could have also checked it this way, which would have ended up giving you the same answer. Maybe it would have been 2.0, and you would have had 10. And then negative 20 times 10, well, 20 times 10 is 200, and then the signs are different, so it's still going to be negative. So now we take this challenging division problem, and we rewrite it as negative 200 divided by 2. And from there, 2 goes into 200 100 times, and the signs are different, so the answer stays negative, and your answer should be negative 100. And notice we didn't go to 1 this time, although you could have. We went to 2, and then we just solved the basic division problem. D is kind of similar. So I'm going to think of D again as a ratio. And then I want to do something to get rid of the decimal to make this an easy problem. So I'm going to use that strategy of multiplying by 10 again. I know that 12 times 10 is 120. And then you could do 4/10 times 10 to the side, but I know it's just going to get rid of our decimal point. It's going to take the 4/10 and put the 4 into the ones place. And it's just going to become this. So this first division problem is equivalent to 120 divided by 4. So now that I have 120 divided by 4, I could actually just do long division here. And when you do that, you should end up getting an answer of 30. Alright, if this was new to you, I think you're ready to try these on your own. For E, you should get an answer of 6. And for F, you should get an answer of 7. And again, keep trying these on your own. For G, you should get an answer of 5. And for H, you should get an answer of 12. Alright, these last two are state test level, so let's kind of go over it together. Notice that this expression, the only thing that's really new is we have something inside the parentheses to do. So we have negative 1/4 plus 1/2, and I'm going to rewrite that as negative 1/4 plus 2/4. And modeling that, it's like we have an elevator that starts in the basement and is going to go up 2/4. So I'm going to go up 1/4 once to get to 0, and then go up another 4th to get to positive 1/4. And so now I know that this whole thing and the inside is equal to just 1/4. So I can rewrite the problem like this. Okay, so if the past 2 days have been easy for you, then that hopefully made sense. From there, we have some options. I think what I'm going to do is I'm going to rewrite 1/4 as 25 hundredths. And then I can keep that one like this. And then what I'm going to do is I'm going to take this division problem and I'm going to think of it as a ratio and just make an equivalent ratio by multiplying by 10. When I do that, 25 hundredths times 10 is basically going to move all the place values over 1, and you'd just be left with 2.5. And then 1/10 times 10, again, the 1 is going to go from the tens place to the ones place. It just becomes 1 whole. And then I don't have to do anything else because anything divided by 1 is itself. So this answer should be 2 5/10. Alright, and this is the level I'm really trying to get you guys to get up to. Definitely, if you think you're ready, try it on your own and then check out the rest of the video to see what the answer is. So we have 3.5 divided or subtracted by 9 3/4. So first, it's almost like we just have a regular subtraction of integers problem, and then we'll deal with this crazy part. So first, I'm going to rewrite 1/2 as 2/4. And then keep 9 3/4 the same. And then I see that this problem is dealing with decimals, so at some point I'm going to need to change everything into decimal form. But for now, I don't really think I need to. So we have 3 2/4, and then we're going to subtract 9 3/4, but first, we're probably going to make it to 0. And then if we're breaking this guy up, I know that we're still going to have 6 wholes left over and 1/4. And as a check, I know that these two things add back up to 9 3/4. And so the inside of these parentheses is -6/4. So that was the first part of this problem. I'm going to take -6 1/4, and I'm going to rewrite it as a decimal. So the -6 is in the ones place, and then 1/4 is the same as 25 cents or 25 hundredths. So now my new problem looks like this, and notice that thinking of division as a ratio is really going to make this problem easier. So we can multiply by whatever we want. I'm going to multiply by 2 because I know that's going to take this 2.5 and change it into a whole number. It's just going to change it into 5 wholes. And then -6.25, oops, almost forgot the negative sign. Be really careful here. That's a -5. Alright, so if I take this and I multiply it by 2, I'm going to end up with 12.50, and it's still a negative. So now my new problem looks like this, and we're almost there. So from here, I'm just going to do long division. I'm going to think of it as $12.50 divided by 5. So 5 goes into 12 twice. 5 goes into 25 5 times, but since I'm past the decimal point, I'm going to need to put that the decimal point right there. 5 times 5 is 25. And then 5 goes into 0 0 times. So there's really nothing else to do here. And then, since we have a negative divided by a negative, it's the same as the multiplication rules. Same sign. They multiply or divide to a positive number. So your answer should be 2.5. And if that made sense to you, congrats, because those problems were way too advanced for my kids last year, and it's pretty awesome if you're there. If not, don't worry, we're going to practice it some more. Thank you guys for doing this tricky homework.